Okay, this is section 4.6, and this is a review of the binomial distribution. And the only thing new is determining if the binomial distribution is approximately normal. And for it to be approximately normal, your sample size times the probability of success has to be greater than or equal to 5, and also the sample size times the probability of failure, Q, has to be greater than or equal to 5. And let's go ahead and do a problem here. So the first one is a straightforward problem from section 2.2, and this one says 34% of Americans have type A positive blood. If 500 Americans are sampled at random, what is the probability at least 300 have type A positive blood? Is this binomial distribution approximately normal? Okay, so first is just getting this probability. So this is binomial because they either have type A blood or they don't. Notice there's no means or standard deviation given on this problem, so it's not like a z-score type of thing. You can do the binomial problems on the binomial sheet, or since we're on the ZNT sheet, I do these at section 4 of the ZNT sheet. I'm on the ZNT sheet and I scroll down to section 4 of the sheet. Now, this actually has an extra feature on it on the ZNT sheet that tells you whether it's approximately normal and the minimum sample size is needed to be approximately normal. So this is a nice thing. This is really a better area to do this problem. So put in your information. We have a sample size of 500. It said the probability that at least 300 have type A positive blood. So at least 300 means 300 or more clear up to all 500 having that type A blood. So 300 to 500, and then put in your probability of success right here, which was given to be a 34% chance that a person has type A positive blood. So put that in there. So your answer is actually 0. So if this statement is true that 34% of Americans have type A blood, then the probability that 300 or more of the 500 people have type A blood is basically no chance at all. That's because when you think about this, how many would you expect to have type A blood? Well, I would expect 34% of the 500 people to have type A positive blood. Well, 34% of 500 multiplying 0.34 times 500 gives you 170. Well, the lowest value that we're getting the probability of is 300, and that is way above 170. So it's very unlikely that 300 would, and even more unlikely that more than 300 would. The standard deviation is only 10, and so most of your scores fall within 3 standard deviations above the mean. So that means almost everybody's going to fall between 140 to 200 on this, and we're looking way up here at 300. So now, is the distribution approximately normal? Well, the Excel sheet right here tells you, yes, the distribution is approximately normal. But the way to tell if it's approximately normal without using the Excel sheet is to see if n times p is greater than or equal to 5. Well, here's your n and here's your p. Well, 500 times 0.34 is 170. That's your mean. Your n times q is going to be the remaining folks. So if you take 500 minus 170, you get 330. You could also get that by doing 500 times 1 minus 0.34. So 500 times 0.66 is 330. And both of those numbers, 330 and 170, both of them are way bigger than 5. So this distribution is very normally distributed. So the answer is yes. The minimum sample size to be approximately normal is calculated right here. This problem didn't ask that, but it's right here. It's 15. Now this graph shows the binomial distribution in red and a normal distribution in black. And you can see that the red graph is basically right on top of the normal graph. So this is very normally distributed at a sample size of 500. But if you drop it down to a sample size of 15, it's not perfectly normally distributed. So we can see this graph here on red is the binomial distribution, but it basically lays on top of the normal distribution. The reason why the red graph, the binomial distribution, goes up in steps is because it's a discrete distribution. So there's a probability of 5 people saying yes, or 6 people having type A blood, but it's not 5. There's not a probability for 5.5 or 5.3 people having type A positive blood. But the Normal distribution is a continuous distribution. It flows like this. So one is a discrete, like bar graph type of thing going up in steps, and the other is a smooth distribution. But you can see that this discrete distribution, the binomial, lies right on top of that smooth distribution. So 15 is okay. But if we go under 15, let's say we have 10, now you can see that that discrete distribution doesn't really fit real good on that. So that's why the answer is no at this. It's hard to identify whether it's a yes or no by looking at the picture, but at least you can tell what's going on. Like if I drop this farther down, let's go down to about 3, you can see that this distribution, the binomial distribution, is real jagged like this and doesn't fit in with this normal distribution. So that's that whole area there. We'll do a couple more, like let's go down to example 3. Example 3 says 4% of college students have a GPA of 3.8 or higher. What is the minimum number of college students that need to be sampled to make the distribution approximately normal? Well, with this one we just have one fact. The probability that a person has a GPA of 3.8 or higher is 4%. So on this one, delete everything else, but for your P just put in 4% or 0.04. Now, we don't get any answer for probabilities. The distribution would not be approximately normal, but right here is the important thing, is that the minimum sample size for this distribution to be approximately normal is 125. Now, the way they did this without Excel is to use the formulas up here, that n times p and n times q has to be greater than or equal to 5. So 0.04, if you put that in for the P, you say n times 0.04 has to be at least 5, so we'll say equals 5. To solve an equation like that, then you have to divide by the P. So I would divide by the 0.04. And 5 divided by 0.04, if you do that on a calculator, that's 125. And so that's, I think that might be shown here where you're doing it by hand. So see, n times the 0.04 equals 5. So you have to solve it for n, so you have to divide by 0.04, and you will get 125. And then I think there's one more. And here's the distribution, and you can see what it looks like at different levels. Like right here, if you have, let's say, 100, it's still, no, it's not approximately normal. But if we go up to 125, this changes to a yes, because this distribution here, the red distribution, which is binomial, is close enough to the black distribution that it's approximately normal. Then if it's approximately normal, you can use z-scores. So the last example is 93% of college students believe that a college degree will get them a better job. What is the minimum number of college students that need to be sampled to make the distribution approximately normal? So again, put the 0.93 right here, and you get your minimum sample size of 72. And again, the way that was done is that it was solved again, the n times p and the n times q. We can substitute the p, 0.93, in for p and solve that equation. And 1 minus 0.93 is 0.07. Put the 0.07 in there for q, and n times 0.07 has to be greater than or equal to 5. Well, you can solve both of these, but your answer is the largest of these two values for n. The largest value for n will happen with the smaller one of these two. The smaller of these two is 0.07. So solving n times 0.07 equals 5, you would divide by the 0.07. So you take 5 divided by 0.07, and you get 71.42. You can't sample 71.42 people, so you would sample 72 people. And that's what the sheet gets for you right there, that you need to sample 72 people. And really that's it with that problem.